Okay, welcome to this first lesson for O-levels. So this lesson is for O-levels, linear motion for O-levels. We're going to be doing 4 tutorials on linear motion. So for you to be a part of this, subscribe. So without wasting much of the time, let's get into it. So, okay, so linear motion is all about equations. When you are form 4, you have no need to worry about how these equations are derived. You just need to know them and you know the variables. Okay, so the variable A stands for acceleration. Acceleration is the rate of change of displacement. And then V stands for final velocity, and which is measured in meters per second. Acceleration is measured in meters per square second. Velocity is measured in meters per second. Then U stands for initial velocity, which is also measured in meters per second. Time, T is for time, obviously in seconds. Then X is for displacement. Displacement and distance they are different variables. Okay, kuti displacement and kuti distance, these are different things, but we'll talk about this in the next tutorial on it. So X is for displacement, which is in meters, but in some cases displacement and distance, they are used interchangeably, but they are different things. Okay, the first equation is saying that A is equal to V minus U over T, meaning that acceleration is equal to final velocity minus initial velocity over time. Okay, then the second equation is saying X is equal to V plus U over 2 times time, meaning that displacement is equal to the average velocity times what? Times time. Everyone knows this equation, even from primary school, that basically primary ends in distance is equal to speed times time. Okay, so displacement margin is equal to average speed, average velocity times time, which is the average velocity is equal to what? Is equal to U plus V over 2 in brackets times time. So X is equal to V plus U over 2 times time. Then the third equation is equal to V squared equal to U squared plus 2AS, right? Then the final equation obviously is equal to X is equal to UT plus half ET squared. So we are now going to be doing certain examples too, in order to make sure you understand this, in order to make sure that you understand these equations further, for you to be able to use them. Okay, so example number 1, we're going to be tackling problems that have to do with the first equation. First equation, right? First equation, we said what? The first equation, we said that A is equal to this is the first equation, right? So the first equation, we said A is equal to V minus U over T. Okay, so let's look at a problem that involves that. Okay, we're seeing that, okay, let's start with A, number 1A. A body initially traveling at 30 meters per second drops to 5 meters per second in 5 seconds. Find the acceleration. That is absolutely easy. We're seeing that V is equal to 5 meters per second. The final velocity. The final velocity of what? The final velocity of the body. Then U, the body was initially traveling at what? At 30 meters per second, right? The initial velocity of the body. Then the body was traveling at 30 meters per second. Then it drops to 5 meters per second. In what? In 5 seconds. Which means T is equal to 5 seconds. T is equal to 5 seconds. So we want the acceleration now. So which means A, according to the first equation, is equal to what? Is equal to V minus U over T. The final velocity is what? Is 5 meters per second minus 30 meters per second. In what? In 5 seconds, right? This all happened in 5 seconds. Okay. So this is now simple. We can see that A is equal to now to 5 meters per second minus 30 meters per second, which is equal to negative 25 meters per second over 5 seconds, right? So we are going to say 5 into 25 into negative 25, we're saying A is equal to negative 5 meters per square second. This is the acceleration now. So whenever acceleration has a negative sign, it means the body was dropping in speed. It was decelerating, right? It was decelerating. Okay, let's look at the next example. The next example is that a body starting from rest. Okay, so whenever a body starting from rest, its velocity is 0. This is the body which is not moving. Whenever you hear a question saying that the body is starting from rest, it means the body was not moving. Okay, so that we've cleared that out the way. All right. A body starting from rest reaches a velocity of 100 meters per second in 10 seconds. Okay, so the body is starting from rest, so which means initial velocity u is equal to what? To 0 meters per second. Then the body gains a velocity of 100 meters per second, which means the final velocity now is equal to 100 meters per second. That's the final velocity. All this happened in 10 seconds, which means t is equal to what? T is equal to 10 seconds. Okay, so now we need to find the acceleration. Easy peasy. According to the first equation, A is equal to V minus U over what? Over t, over time t. Okay, we can see that the final velocity is 100 meters per second, which is 100 meters per second minus 0 meters per second over time 10 seconds, over time 10 seconds. So A is equal to this. We can see that 100 minus 0 is going to be 100, right? So A is equal to 100 meters per second. 100 meters per second over 10 seconds, right? So, okay, I put 10 there. It's going to be 100 meters per second. So, obviously, our acceleration is 10 into 100 is going to be what? A is equal to 10 meters per square second. That's the acceleration now. Okay, the unit of measurement is very important. So, 10 is equal to A is equal to 10 meters per second. That's the acceleration. So there's no negative now, which means the body was increasing in velocity. Okay. Now we're moving to this. So just to clarify, we've done two examples pertaining to this first equation, right? This is first equation. We say A acceleration is equal to final velocity minus initial velocity over time t, and this is done. This is done. We are moving now to the second equation. The second equation, which states that let me take a clean sheet. So the second equation is saying that x, which is displacement, is equal to v u plus v over 2 times t. So that's the second equation. Okay, let me put 2 here. I'm sure you're seeing that clearly. That's the second equation. So right now we now want to tackle problems that are related to this second equation of motion. Okay. So in the next lesson we're going to be tackling vertical motion, right? Vertical, like throwing something up in a linear fashion. Okay. So for the moment we're dealing with horizontal. Linear motion, but in a horizontal fashion. Okay. So we need problems that are related to this equation. So the first problem, okay, we can see that. All right, this is the first problem, right? A body travels with a constant velocity of 15 meters per second for 10 seconds. Calculate the distance traveled in 10 seconds. Okay, the body traveled for 10 seconds with a constant velocity. So when a body has constant velocity, it means the velocity isn't changing. Okay, the velocity isn't changing. So the final velocity and the initial velocity are going to be the same, right? So it is a constant velocity of 50 meters per second. Okay, so u is going to be 15 meters per second, right? Then v, final velocity, is going to be 15 meters per second. And this body traveled with constant velocity of 15 meters per second for 10 seconds, right? So t is equal to 10 seconds. So ultimately we want the distance it traveled in 10 seconds again. So for the time it was moving, we want the velocity. All right. So this is a very, very easy and straightforward question, right? So x displacement is equal to u plus v over 2 times t, which is the average velocity. So we're going to say x is equal to 15 plus 15. So it's 15 plus 15, right? 15 plus 15 over 2 times 10, which is the time. So obviously, x, without wasting time, is equal to be 15 times 10. So x obviously is going to be 150 meters. So this body is going to travel 150 meters for the 10 seconds it was moving. Okay, so we are moving on to the third equation. Just hope I'm not moving so fast. We're moving on to the third equation. The third equation, which is saying that okay, I want you to listen, to pay attention much more closely this time. So v squared is equal to u squared. V squared is going to be u squared plus 2as plus 2ax. So this is the third equation, right? This is the third equation. Okay, so when you're dealing with these equations, it's okay to substitute in some cases, even in all cases if it's appropriate, if it's necessary, I mean. So v squared is going to be is equal to u squared plus 2as. So we're going to tackle a problem that is related to this equation. So okay, so this is the question for example 3. A car of mass 1000 kilograms traveling at 36 kilometers per hour is brought to rest over a distance of 20 meters. Okay, so this I want you to take note here. This value is in kilometers per hour, right? Is in kilometers per hour. Okay, so 36 kilometers per hour, if you convert it to meters per second, is going to be 10 meters per second. Okay, so I want you to take note of this. The reason why I converted 36 kilometers per hour to 10 meters per second is that we are doing all the calculations in meters per second, right? So 36 kilometers per hour, if you convert it to meters per second, it will lead to 10 meters per second, right? That's easy peasy. All right. I'm going to read the question again for clarity, okay? A car of mass 1000 kilograms is traveling at 36 kilometers per hour, is initially traveling at 36 kilometers per hour, which means u obviously is going to be equal to what? U is going to be equal to 10 meters per second. That's u. u is going to be equal to 10 meters per second. Then it's brought to rest. When something is brought to rest, it means it was brought to a stop, which means the final velocity v. Final velocity v is going to be equal to what? V is going to be equal to 0 because it was brought to rest. And so it was brought to rest over a distance of 20 meters, right? It was brought to rest over a distance of 20 meters, which means our x is equal to what? X is equal to 20 meters. Okay, so question 3 wants to tackle this problem. We're going to use this equation. V squared is equal to u squared plus 2as. Obviously, we're going to make a the subject of the formula because the question is saying find the average retardation. Retardation means deceleration. So deceleration is just acceleration with a negative, right? With a negative sign. Okay, so if we make this equation subject of the formula, we're going to end up with a is equal to what? V squared minus u squared over 2x, x which is the displacement. Okay, so in this case, even a grade 7 can finish this question. All right, v squared is equal to 0. Okay, so 0 squared is equal to what? To 0 minus 10 squared. U squared is equal to 10. Okay, u squared is equal to 10. So 10 squared now is equal to what? 0 is equal to 10. 0 squared is equal to 0. Then 10 squared is equal to 200, which is 0 minus 100 over 2 times x. X is equal to what? 20. So it's 2 times 20. So we are seeing that 0 minus 100 is going to equal to negative 100 over what? Over 2 times 20, which is 40. 0 cancels 0 here, right? Then 2 into 10, 4 into 10, 4 into 10 is going to be equal to 2.5. Negative. So negative 10 divided by 4 is going to be negative 2.5. But this is, we are calculating acceleration. The unit for acceleration is meters per square second, right? So it's going to be negative 2.5 meters per square second. That's the average retardation. Retardation just means deceleration, which is acceleration with the negative sign. So this is the solution for example 3. Okay, so to those of you who are failing to understand this, don't worry, we have I'm going to be doing 4 lessons on this. So for you to be safe, just subscribe. Then whenever I'm uploading the next lesson, you'll be in touch. So we are done with example 3. So we are now moving on to the last equation of motion. This is horizontal motion, linear motion in a horizontal fashion. So the last equation goes like this. Okay, then the last equation, equation 4. Equation 4 goes like this. X is equal to ut plus half at squared. At squared. So this is the last equation of motion, right? The last equation of motion. So for the moment, we are tackling questions in a horizontal fashion. Okay, the next lesson will be vertical motion, linear motion in a vertical fashion. So x is equal to ut plus half at squared. This is, so for form 4s, this is for O-level. I will repeat again. This is for O-level. So for form 4s, you don't need to worry about how these equations are derived. Okay, you just need to worry about knowing them. So you can just know them by heart and apply them in the examination. Okay, so x is equal to ut plus half at squared. Let's look at a question. For question 4, okay, like enough, we have space for explanation. Okay, so this is the question for This is the question for this equation. We're going to use this equation. X is equal to ut plus half a t squared plus half a t squared, right? This, we're going to use that equation. So a bullet of mass 20 grams traveling with a velocity of 16 meters per second penetrates a sandbag and is brought to rest in 0.05 seconds. Okay, calculate depth of penetration in meters. Okay, okay, I'll read the question again. A bullet of mass 20 grams traveling at a velocity of 16 meters per second penetrates a sandbag and is brought to rest in 0.05 seconds. Calculate depth of penetration. How deep did the bullet penetrate into the sandbag? Okay, so we've we need to calculate the depth of penetration, which means the distance or displacement the bullet went into the sandbag, which means we're going to calculate x, right? In this example, there's no need to make anything rather than x the subject of the formula, of which x is already the subject of the formula. Okay, so but we have two unknowns. We have x, the variable which we want to calculate, right? Then we have a, we don't have a, right? The acceleration or deceleration, whatever. Okay, so we have u. The initial velocity, the bullet is traveling at 16 meters per second. That's u. Then we have t. T is equal to 0.05 seconds. 0.05 seconds. Right? But we don't have a. Because our equation is saying what? X is equal to ut plus half et squared. But we don't have a. We can first calculate a. A is equal to what? Okay, so whenever you're doing kinematics, sometimes you're going to link these equations, right, for you to find the answer. That's why I'm saying that it's very beneficial for you to subscribe, then stick to the 4 tutorials I'm going to upload. When we're done with these 4 tutorials, kinematics, O-level kinematics will be walkover to you. It will be walkover. It will be something which is very easy. It has always been very easy, but I don't know why students find this very hard. Okay, so we want to calculate a now because we don't have a. So according to the first equation, we said a is equal to v minus u over t, of which what is v? The final velocity. What is u? The initial velocity. Okay, so the bullet traveling with a velocity of 16 meters per second, that's the initial, right? So, and is brought to rest in 0.05 seconds. That means the bullet went to a stop. When something is stopping, the velocity is equal to 0. Obviously, so the final velocity now is going to be equal to 0. So a, the acceleration we want to find, a is equal to 0 minus what? Minus 16 meters per second. Minus 16 meters per second. Minus 16 meters per second, because u is equal to what? We said u is equal to 16, right? Then the final velocity is equal to 0 because the bullet was brought to rest. Then the other thing I want you to look at here is that the time t brought to rest in 0.05 seconds. Okay, 0.05 seconds. That's when the bullet went to rest. So obviously we're saying that negative 16 over 0.05 seconds, meters per second. So we are saying that we have a negative. Whenever we have a negative, it means the body was decelerating. We've talked about this. It means the body was decelerating. It means the body was decelerating. Calculator. I was looking for my calculator, so it took a while then. Okay. So we have what? We have 16. We have 16, right? We have 16 divided by what? By 0.05 seconds, which is 320. 320. So do not forget that we have a negative. So this is going to be a negative 320 meters per square second, right? So the bullet was decelerating at a rate of 320 meters per square second. That's very huge. Okay, so but the question didn't say find the acceleration. We're just finding the acceleration because it's an unknown variable. Okay, so we want to find what? The depth of penetration in meters, right? How the distance the bullet went into the sandbag, right? So, okay, some of you might think I'm too repetitive. I'm too repetitive because I don't want you to get lost. Okay, so at this point, we're just going to substitute the values of the variables, right? So x is now going to be equal to u. U is equal to 16 times 0.05. We talked about this. 0.05. Ut, x is equal to ut plus what? Half at squared. Okay, so plus half a is equal to negative 320. We calculated this. Negative 320. So it's equal to half, in brackets, negative 320. T squared, 0.05 seconds. Then you plug this into your calculator. Right? You plug this into your calculator. Then you come up with the solution. Okay, let me just do that with you. Okay, so okay, we are seeing that 16 times 0.05. 16 times 0.05, which is 0.8. So ut, in this case, x is equal to ut. Ut, which means 16 times 0.05, which is what? 0.8 plus half of negative 320. Negative 320 of negative 320 times what? Times 0.05. 0.05 squared. I just hope you're seeing this. 0.05 squared. Use your calculator again. Okay. 0.05 times 0.05, which is 0.0025 times negative 320 times 320, which is 0.8 again, divided by what? Divided by 2, because it's half at squared, which is 0.4. So x is equal to what? 0.8. 0.8 plus negative 0.4. Okay, so we are now simplifying. X is equal to 0.8 minus 0.4. Negative times negative times a positive is going to be equal to a negative. So negative 0.4. Obviously, x is equal to what? 0.8 minus 0.4. X is equal to 0.4 meters. Distance is measured in meters. So which means the bullet penetrated 0.4 meters into the sandbag. Okay, that's it. So thank you very much for watching. I hope I'll be seeing you in the next video.